Lesson 04 is on nth roots and real exponents. You've been taught how to work with square roots, and today we're going to talk a little bit more about cube roots and fourth roots and fifth roots. So in general, we're going to talk about nth roots and also discuss some properties of exponents, which you've learned in the past. So first of all, example 1 says find the nth root. Number example 1, letter A. Real simple, we've got a square root of 49, and there's a negative sign in front, so the square root of 49 is just a 7. We'd have to leave that negative sign in front. Pretty simple problem, just knowing your square roots. Letter B, we've got a cube root this time, and we've got a fraction. So anytime you got a fraction inside of a root, you can split it apart. So that's the first thing I'm going to do is split this fraction apart. It remains a third root, but it's the third root of 64 over the third root of 27. Now we can actually take the third root of both of those numbers. The numerator gives us a 4, denominator is 3. That's your simplified answer. Letter C is a fourth root of negative 121. Well, with square roots, we have when we have negatives inside of square roots, we end up getting imaginary values. But when we have fourth roots, sixth roots, eighth roots, we're just going to say that it's not real. Again, that's just on an even exponent. If you had a negative inside of an odd exponent, you can calculate the third root, for example, of negative 27. So any odd root, you can evaluate that root of a negative. Example 2, we're going to simplify using absolute values. And we're going to use variables on these. So on part A, we've got the 6th root of n to the 18th. Now anytime you got an even root, like we have in part A, and you end up getting an odd exponent. So on this example, 6 goes into 18 3 times, so our answer is going to be n to the third. But we need to have absolute values around that answer to ensure that it's positive. Again, we use absolute values anytime we have an even root, like we had in part A, the 6th root, and you end up getting an odd exponent like a 3. Moving on to letter B. I'm going to break this apart. We've got a fourth root right here of 81. And we also have fourth root of the expression a plus 1 to the 12th. So if you take the fourth root of 81, that gives us a 3. And if you take the fourth root of a plus 1 to the 12th, it would give us a plus 1 to the third, because 4 goes into 12 3 times. But this situation, again, we took an even root, fourth root, got an odd exponent. So I need to have absolute values around that expression to ensure that it's positive. Letter C. This time we've got a square root of 63. I'm going to break that apart into the square root of 9, square root of 7. And then we also have the square root of y to the third. So the square root of 9 obviously is a 3. And now I'm going to take this square root of y to the third, and since 2 goes into 3 once, I need to have a y to the first outside of the square root. And then inside the square root, I got to have a 7 and a y left over. I do need absolute values around that y because it was an even root and it came out with an odd exponent. If you look at letter D, again, we've got a negative inside of an odd root, so that negative sign is going to come out. And now we ask ourselves, how many times does 5 go into 10? That answer is 2. So I got a p to the second. And then how many times does 5 go into q? Sorry, into 7, that's once. So we got a q to the first. We will have to have a fifth root of q to the second left over inside. And we do need absolute values around that q to the first. Actually, we don't. I'm sorry. My mistake. That was an odd root, not an even root. That is not needed. My mistake. Okay, example 3. Let's do letter B first. Continuing with these variables in an even root. So 4 goes into 21 5 times, so that's going to give us x to the fifth. We are going to need absolute values around that. And now let's go on to the y variable. 4 goes into 15 3 times. We are going to need absolute values around that as well. But then we've got left over x to the first and y to the third. So there's our expression involving absolute values on part B. Now in part A, this problem's got a 10th root in the numerator and a 6th root in the denominator. So what I'm going to do is I'm going to rewrite these as fractional exponents. 32 to the 1/10 is the numerator. 2 to the 1/6 is the denominator. Now, if the 32 and the 2 were the same number, we could use properties of exponents and we could take those exponents and subtract them. So I'm going to change the numerator into 2 to the 5th, and we still have that raised to the 1/10. Denominator stays as 2 to the 1/6. Well, now what I can do is I can rewrite that numerator as 2 to the 1/2. Denominator stays 2 to the 1/6. Now I can subtract those two exponents. So this gives us 2 to the 1/2 minus 1/6. And if you take 1/2 or 3/6 and subtract 1/6, you get 2/6, which is 1/3. And that would be your answer with a fractional exponent. If you preferred to write it like this, you could do that as well.